hostess, because sometimes I think it's important for people to know what to expect when they have equipment that they're going to buy. You know, you don't have unrealistic views of, you know, what you can achieve. So so the book starts off, it goes through sort of the basic. You can use a DSLR with a widescreen camera, but you're not going to get much detail of the moon. It's more of a landscape shot, up to sort of zoom lenses, stabilized on a tripod, attaching to a telescope. I get lots of questions about people saying, how to attach a camera to a telescope. So the book covers that. You know, it tells you what sort of fixtures and fittings you need. And then you get lots of questions of like, well, how do you get so close to the moon? And you know, it's how it's all related to the focal length and the sensor size and the field of view. So I go into all these details in sort of a picturesque way to make it easy in a non-jargon format.
That sounds great. Do you do other sorts of astrophotography? I mean, not just lunar. Do you do planetary and do you do deep sky?
Yeah, I've got an interest in all forms of astrophotography. So I've got an Esprit 80 ED telescope as well. So I generally just use that with my Canon 6D. So I don't do any narrowband imaging. It's more just, you know, just normal photography with a DSLR through the camera. But, you know, you can get the brighter targets such as Andromeda and some of the brighter nebulas. So I enjoy, you know, all aspects of it. So it's that time of year now, you know, we're getting there.
Well, we just need a clear night now. I mean, I don't know what it's like for you, but it's cloudy again.
It's terrible, actually. I've not been a chance to get out for a long time. So I'm just sort of itching now that the moon's up as well, and I want to get out, but you know, just rain. It's typical of Yorkshire. And probably UK actually.
Well, yeah, because I mean, I live on the North Welsh border, and we just get rain constantly. So just one or cloud. And Ron will echo that, because Ron doesn't live too far from me or Daz, and they both. You know, we experience this thing called the Cheshire Gap, where we get funneled cloud through, and it just comes over here, and then we send it on to Bradford afterwards. You see,
you do, but I suppose that's one benefit. I suppose that's one benefit of lunar photography. You can get the gaps in the clouds quite easily, whereas the longer exposure stuff, you need a long clear night. You know, so I can balance it with the lunar stuff fairly easily.
So, what inspired you to write the book?
Well, the reason I wrote the book is because I've been showcasing a lot of my images online, and I've been getting a lot of questions from people coming back saying, how do you produce these images? How do you attach, you know, your camera to a telescope? All these sort of questions, which I'm thinking, and like questions like, how do you produce a good image? And it's not an easy thing to answer, because there's so many stages in that process. There's your equipment, there's how you set your equipment up, there's your capture techniques, there's the stacking techniques, then there's the processing. There's so many things that you know, there's no like easy answer to say this is what you do. So as much as I can help people, I thought it'd be a good idea just to put all this down in a book actually, and just help people in that sense, because you know, you obviously you've got a lot more time and space to do that.
You're gonna like this one, James. It's coming from Stefan in the Russian Federation.
Okay.
Outside of Moscow, and he said, "You are to the moon what Damien Peach is to the planets."
Oh, great! That's a nice comment. I love that.
Yeah, so that's a nice one. And
he
said he's ordered your book as well. So
oh, excellent.
So you got one going out to Russia as well. So what I'm going to do, I'm going to hand over to the panel. That we got a panel in here tonight on Astro Radio, and they'll ask you a few questions. So I'll hand you over to Dave, and he can lead the questions.
Okay, thanks, Pete.
Thank you, Pete. Hi, James. Good to have you on board. Absolutely amazed by the book. I love it. If I was to write a review, which I've never ever done a review for a book, how would I describe it? It's a practical book for the beginner that the well-hardened observer would love. The images are just outstanding. The sharpness, the clarity, the resolution is beautiful. The actual book, it's glossy hardback. It's just great to have it sitting there. It's not something that you can have on the screen and enjoy as much. I opened it up, and that smell of the fresh book just came out, and the images, you know, it's got images that I recognize. The crazy. Looking at the front cover, what we got, Copernicus. We got
Archimedes.
Archimedes. Copernicus is just off, and then we got the Apennine Mountains.
That's right.
Yeah, I mean, that is stunning, just that front cover. If that was on the bookshelf, it's the one that you go, you know, people go for the book cover. That's what you judge that book by that cover and go, okay. And when you open it up, wow. And it covers everything from, as you say, putting the camera onto a telescope to processing those images at the end. The thing with your images, the difference is that they're not just black, white, and greys. You've got colour. And when we look at the moon, we tend to think of it as this black, white, grey world. But it does have very subtle colouring. And you bring that, you enhance that colour to the point where you can actually work out maybe the mineral deposits.
Yeah,
can you explain basically what that's about?
Yeah, I mean, that's the style I've developed, and I think processing these images in colour, it brings out so much more. So with the modern processing techniques, it allows you to do this, because like you've sort of alluded to, the moon is actually a variation of different minerals, and it is actually colourful. However, it's just too faint to see. So if you enhance these colours using modern processing software such as Photoshop, then you can actually see much more within an image than you can from a mono image. You can see all the sort of creator ejector. You can see how the ejector overlaps other creators. You can see features that are normally hidden in normal black and white mono images. And I think when you look at the colour images, and I've had comments from lots of people, they're just like, wow, I didn't realise the moon was coloured. And to the eyes, it's not per se, but you can bring that colour out. And the images just look a lot more striking to the eye as well. And it kind of draws people in a little bit.
Yeah. When I first saw this technique, going back a good couple of years now, I just thought, well, wow, this is interesting. And I know certainly members of Manchester Astronomical Society took it upon it as well. And they were pushing it out there. You know, look at this colour. People were saying it's not real, it's not true. And then NASA started producing images with their findings of mineral deposits, and it did actually match. There was some, reference there, so that was good.
Yeah, I mean, what I always say to people, say it's not real, it's not true. I said, well, have you ever seen Andromeda through a telescope? It looks like a fuzzy blob. Have you ever seen some of the like Orion Nebula through a telescope? It doesn't look like you see in a magazine. So the colour is enhanced in post-processing for all astronomical targets. So why not the moon? You know, you could say it's not natural, but it kind of is. It's kind of an intermediate between science and art. It's quite a good way of doing it.
That's it. Getting the science out of that is amazing. The other comment I'll make about the book, if I was going to promote it, I would say it's inspirational.
Yeah,
and that's what astronomy is about, isn't it? To inspire others to follow. Some people keep the secrets very close, you know, their methods very close to their chest.
Yeah,
yours are
absolutely.
out there in the book.
Yeah,
brilliant.
Yeah. And that is, I completely agree with what you say there. Actually, a lot of people don't always give the tips of how they produce the image, and I didn't want to do that, like you've alluded to. I wanted just to share that knowledge with people who start out, because the image processing can be difficult. You know, that was the difficult bit for me when I first started out. It's like a bit of a dark art. You can sort of get your software, you get your program up, and you think, where do I start? I've just absolutely no idea. And you sort of pick your way through it slowly, and you get there eventually, and you find a technique that works for yourself. And that's kind of what I've done, and I've put that down in simple terms, step by step, in my book, and hopefully people find that useful.
Certainly do, yeah. I was going to mention Clavis. I mean, I'm curious what mineral deposits around the surface of Clavis, but perhaps we'll come back to that in a while.
Okay.
We'll hold that one for a little while.
Okay.
I'll pass over to someone else. Anyone else got any points, any questions? You can tell I'm very enthusiastic about that. Great stuff.
Frank, you're muted. Okay, Frank. Oh, you're muted again now.
There we go. All right. Hello. Nice to meet you, James.
Nice to meet you.
I realize I've seen your pictures before. Nice to put a face and a name with them. And obviously, if you're coming compared to the work of Mr. Peach, that's a good thing too.
Well, that's an awesome thing, yeah.
I guess one of the things that I'm wondering is I saw a picture recently, and it may be you, and they were talking about the fact that it was a picture where they had followed the Terminator. Now, being just a visual guy when looking at the moon like I did in the past, I would always go up and look at the Terminator on nights when I saw my most definition. Yeah. And this statement is that the entire moon was photographed with the Terminator across it at all different places. Is that something that you do, or is that?
I know which image you're referring to, and that wasn't me. I can't remember the name of the photographer that did it. But yeah, he got quite a lot of airplay actually and a lot of papers took his story and ran with it. But yeah, I think the Terminator is where the definition is from the shadows, and every night's a different night when it comes to lunar photography because the shadow's in a different place. And right. I think what this photographer had done is I think he must have taken the sort of the high definition areas and sort of basically stitched them all together and made one composite image, which when I saw the image I thought, yeah, that's a good image, but it wasn't mine. But I do understand why he took the Terminator region, because that's the area that I would aim for usually when I'm looking at sort of close-up images, because you can get nice shadowed features, of the mountains and everything.
Well, the definition I see on some of your images, so you're able to do that with a completely different technique, obviously, then also.
Yeah. I mean, the technique to get so close and so sharp I use is with a high frame rate camera, which cuts through the seeing, which can be a major problem when you've got really high focal lengths, as you probably know. So and you can take sort of thousands of images, stack a percentage of those, and then post-process using software such as Photoshop, which is how I do all my images really. But
so are you generally shooting at a lower light level then? Obviously, if you were trying to shoot on when it was really bright, you'd have that washout situation that you could solve. Right?
Yeah, so if I'm working at the Terminator region, it's actually not too bright at that point. So you don't overexpose the craters, which you could do if you go a bit further out from the Terminator region. So I generally expose my images to the brightest part I can see, because I don't really like to overexpose any of the craters. So the brightest crater I see, I'll expose to that. And you can look at the histogram in your capture software, such as SharpCap, just to make sure that you're not overexposing the image, because as soon as you overexpose it, you've kind of ruined it. The pixels become, you lose all the color and definition. Yeah, that's right, saturated. So, that's the reason I use. Oh, sorry. So SharpCap. If you don't overexpose the creators themselves.
Yeah.
And then you stack the image and produce a final image as per that.
Okay.
Beautiful, just beautiful. Thank you.
Andrew McCarthy. That was the imager. Yeah.
I've heard the name.
That name. Yeah. I think he's done quite a few Luma images actually.
A question in from Nat, and she's in Brazil, and she said, if you had to pick your favourite area of the moon to photograph, which area would it be?
Yeah, I actually like the Plateau area, Plateau crater, and the mountains surrounding that. I think it's a really nice area to photograph as well. The shadows always look really nice, and you get some really nice jagged peaks over Plateau when the sun's low as well. And it's always a challenge to try and get the craterlets in Plateau crater as well on the smooth surface. If you've got a really clear night, you can actually pick out some of the really small craterlets as well. So I love that area.
And Jill in Dublin said, have you photographed the ISS doing the transit across the moon?
I haven't actually, but that's on my list to do. I have done an ISS pass before, and it is quite an art form to try and keep it in the field of view while it's travelling past. But to do it past the moon, that is on my list to do. Not done it yet.
Okay, well, what we're going to do, we're going to go back to a track now, and then we'll come back to the chat area in straight after this track, and we'll stick to the theme of moons tonight. This is Rory Gallagher and Moonchild.
I was going to say, I think I seem to remember Dave Ratledge, one of our observers in the north, actually put together an A to Z of features on the moon. So it was the lunar A, the lunar B, right through to Y or Gamma.
Just the night before, the Barrow crater, just the night before, off of one of these lists I saw, it has a crack in the wall of the crater where a light shines across the bottom of the crater.
Pitchnatus, I think that is,
every 7 or 8 months only.
Of course, the lunar X, the lunar Y, it can be calculated when they're all observable throughout the year. Mary McIntyre, who's one of our panelists and guests, she does some lovely lunar sketching, and she does the calculations when the lunar X and Y and so on are going to be visible. So maybe we could ask Mary if she would get that file put together, and we could put it on the Astro Radio Facebook site.
Yeah, well, last night there was the eyes of Clavius visible. Yeah. So again, that's another one, which is two prominent craterlets within Plateau, within Clavius. Sorry,
I know somewhere there's a smiley face. I can't remember where that one is, but it's a little smiley face. Yeah.
And there is this, I like looking for sort of obscure objects, and one of the first things I looked for when I was a kid was the ghost crater near Copernicus.
Stadius.
Stadius, yes, that's right.
Yeah, beautiful, that one. Yeah.
I was so excited when I was a kid that I saw that for the first time. Because where I lived in the middle of, well, just outside of Birmingham at the time, and obviously light pollution was pretty bad there as well. And I was able to, the moon was the first thing I really started looking at. So.
Because what I always see now is that we don't see it very well from the northern hemisphere, but somebody from the southern hemisphere, they see it upside down. They see it the wrong way up. But you can actually see a T-Rex heading a football.
Yeah,
that's all I can ever see. Is how I look at it from the southern hemisphere. A T-Rex has got little arms and he's heading the football. Because. I don't know if you can see, where am I pointing? That's the ball there, so his head's over here. Over there. So, of course, you have to see it up the other way, and he's got his tail and everything. So, you can. It's what you want to put into it. It's like the rabbit, isn't it? People can see a rabbit. Old lady's head and things like that. So,
What medication you actually on, Does?
Wilma Flintstone. My wife only sees Wilma Flintstone. That's all she ever sees when she looks up there.
Wilma Flintstone.
I was going to say, Pete, one of my favourite objects I love looking for is Hadley Rill. The reason being is where Apollo 15 landed. And when you look at the mission images, the video, the video that they shot, you actually see them pull up the rover right up to the edge of Hadley Rill. And when you look at that in your telescope, you can go right on that little bend there. That's where they were. And you know where they parked the car as well. That's the beauty of it. Libration is a good thing as well. You've got to get the moon rocks back and forth, east and west, north, south, east and west. So it's rocking. Sometimes it comes towards us, sometimes it's a little bit further away. And that causes some of the craters to be elongated or circular. And you get a better image depending on that libration. That's something worth taking into account when people can't see these objects.
Yeah, that was something I was going to ask.
Especially very fine detail.
Whether you make an effort to go and look for those bits which are rarely seen or which only occasionally come into a decent view.
Yeah, absolutely. I mean, I like to image, as much of the moon as you can. You can see probably 50% view, but I think with the libration, it's probably nearer 60%, I think, overall. So you can get these other obscure areas that are not always seen. And I love to, to do that as well when weather allows. you know, you can see mountain ranges. There's certain sea areas that you can see, and certain craters that usually dip behind the liberation areas. So yeah, I find that extraordinary, to be honest. I do like that part of it.
Because one of the projects that was prominent in the last couple of years was the polar regions, where those craters are in shadow all the time. So as it nods towards us, you get a better view of that crater. Maybe just see the crater wall, but it's what's going on deep in those shadows, which brings us more or less back to the news today from NASA.
Yeah. No, I mean, I do like looking inside the craters and just seeing, you know, the walls of each crater and how a lot of them differ. You can see the central peaks, and every crater is unique. It's quite extraordinary, really.
Yeah. Do you ever leave the telescope motor off and just let the telescope have the moon sailing through, and you're flying across the moon?
Yeah,
it's just.
I do. It's actually quite amazing to do that.
It's quite stunning, isn't it? And you might as well just be.
I love it. Yeah.
You're in your Eagle, or you're in your module there, where they're just flying around.
Yeah, no,
great feeling.
Absolutely.
A question coming from Rob. Rob's in Wellington in New Zealand. And he said, why does the full moon appears sometimes higher in the sky and sometimes lower in the sky?
Well, I think it must be because the moon, I don't know if it's because of the Earth's tilt, and depending where we are within the Earth cycle and the moon cycle, I think sometimes it does rise and fall, depending where we are within that cycle.
Yeah, it's got to be. I think the moon's
it's not quite
tilted to against ours. So, like you say, different seasons we get the moon at different.
And it's my understanding, if you take all those tilts into account, it's something like 16 years before the moon ends up at the exact same spot in the sky with the exact same tilt again.
Yeah.
Sorry there, Ron.
Yeah, what are you going to say, Ron?
I was just going to say the moon's orbit is tilted at 5 degrees above the ecliptic, which is our own path, our own orbit projected onto the sky. So if you, from your particular latitude, if you think how far north and south the sun goes during the course of a year, from, you know, in the height of summer in the northern hemisphere, the sun is very high in the sky at midday, but the moon's is tilted another 5 degrees on top of that, so it can actually go even higher, and conversely it can go even lower at the other extreme. And we've seen it in the last couple of months that in the northern hemisphere that the moon is very low. But we know that by the time we get to December and January, in the middle of the night, the moon will be very high in the sky. And I'm not familiar with which way round it works in New Zealand, but it will be very similar.
Yeah, I say we'll just turn everything opposite in New Zealand. It's all upside. They're all upside down. We have one regular listener to Astro Radio from New Zealand, and I think he tuned in 7 years ago when we started. He's never tuned out. Michael, and I know he'll be listening, but I would say he lives in Oompa Loompa land, and they're all upside down. So, go on, Daz.
Just sort of like following on from the height in the sky and all that. I'm looking at the moon over my left shoulder now, and it's quite high in the sky. But 4 nights ago, it was hardly getting above the hedge line. So so nice and bright at the moment through the trees. So yes, it you can notice a difference within days as it comes around. But it's all to do with ellipses and things like that. And of course, as you said. We see the moon the right way up, and down south they see it upside down. So yeah.
But I suppose the argument is when you're in space, there's no up and there's no down.
No.
Marcus is in Uppsala in Sweden said, "Have you got a preference on makes of DSLR, or are you pretty happy with any sort?"
I mean, the DSLR. If you're talking Canon or Nikon, I mean, I'm used to Canons, and I'm completely happy with a Canon. But I've seen images from both cameras, and I think it just depends on your preference, really. I don't think there's a right or wrong way to go with that. The camera I use is called the Canon 6D, and it's it's quite a premium model, but it's very, very good. But I wouldn't you know, I've seen images with a whole host of Canon, and they all produce good images, to be honest. So no preference really, but I do use a Canon, but only because that's the camera that I bought. There was no reason why I didn't buy a Nikon as such.
So there's a chap, he always plays me up down in he's in Herstmannsue Astronomical Society, and he's a professional photographer, always uses Nikon, and every time I go down there with my Canon, he just says it's EOS, and I said, yeah. He says Etch a Sketch.
Etch a Sketch. Yeah.
So we're going to send him an Etch a Sketch as a gift. So I mean, I've as far as fast frame rate cameras go, you know, using fire capture or sharp cap, I tend to use point grey. Have you used point grey at all, Grasshopper?
No, I've not actually. I mean, the cameras I use for my frame rate cameras are just the ZWO cameras. So I have an ASCII 224 MC and an ASCII 178 MC, which are the both colour cameras. So I tend to shoot in colour as opposed to mono and then use the filters. I find it easier really more than anything. So they're the cameras that I'm familiar with. I've not really used any other high frame rate cameras other than the ZWO. Yeah,
I mean the point grey one, the one that I use is mono anyway. So it's you know, I'm not going to get anything unless I put colour filters in. I'm not going to do that. But I think the frame rate's pretty good. It's around 256.
That is very good, actually.
The origins of these cameras, Pete. The origins of these cameras were industrial. So if you can imagine the assembly line where there's 1,000 biscuits going past a minute, and then someone sends a packet back saying, "I've just found a nut or a screw in my biscuits." They will then look at the batch code, find out exactly when that was manufactured. They will look at the video footage that may be doing anything up to 100 more frames per second, and they will look for when that nut and bolt was on the side of the metal, and then when it was gone, and they will know exactly when. They'll identify it right down to that part. That's why they came on the market, industrial. So we're just benefiting from that technology, aren't we?
Yeah, I mean it's amazing technology, actually.
Yeah, it certainly is.
Yeah, absolutely.
Point Grey itself actually is a surveillance. They are a surveillance company rather than an astro camera company. Where ZWO is an astro camera company, where Point Grey and the FLI cameras are basically surveillance cameras. So it's they've just been developed from that and had additives on and screw on bits to make it fit the telescope. Frank?
James, have you come across or gone looking for any transient lunar phenomena at all that you've been working? What you've been looking?
I was looking for like a Mars transit, but I've not had a chance to get that because of the clouds. I think there's going to be another close Mars transit soon, which I'm going to aim to get as well. But I've not actually physically got any because I've just been unlucky, unfortunately.
James, what about you? Have you ever come across TLPs, translunar phenomena?
Right, that's what I was.
But basically where there may be gases coming out from the rills or the craters or wherever.
Meteor strike.
Yeah, maybe meteor strike. Yeah.
I keep looking, hoping to find one. So I'm thinking one day. I hope I do, but I've not come across any just yet. So it's on one of my lists of all-time greats if I find one.
You never know. You might get one of those reddish glows and think, interesting mineral there. Yeah,
absolutely.
Who knows?
I was saying, I found one. I saw one back in 1997, which was confirmed at the time. So I have seen one, but it's the only one I've ever seen. I never saw anything ever again. So whether
I think if I keep looking at the moon, I'll see something unusual one day.
Yeah. Anyway, we're going to go to another track now, and this is the Scorpions, and of course we're sticking with the moon theme, and this is Dancing with the Moonlight. Your video's froze, James.
Yeah, I'm just seeing that. Yeah, let me.
I thought he was in shock there.
I thought he looked like he was in shock there. Yeah,
he looked like in shock. Well, I was like,
we were talking about the lunar reconnaissance the other day, and we were talking about again translunar phenomenon.
There's something wrong actually. Failed to start video. Let me see.
We can still hear you though, James. Your audio's okay.
Right.
Invariant, which
There you
basically
had
means
Blackmore's Night and Dancing with Moonlit. Dancing in the Moonlight. It's a lovely
Simon, have you got any moon on show?
The transit of the moon, says Richie Blackmore and his dear lady.
Economy.
Anyway, this is Pete. This is Astro Radio. Facebook.com/group/Astro Radio. Earth. Pete at astroradio.earth. This is Reach Out and Touch Space. We're going to go back over to the panel now. And the question has come in from Tien in Japan. I knew we'd get a question in eventually. And he wants to know how long it would take to walk around the moon. Now, who would like to answer this question? Anybody in particular?
What are we going to go around the equator, the lunar equator?
He just said around the moon, so I just imagine
well,
around the equator.
It depends on how big your legs are, of course. I'm only 5'4", so I've got little legs. If you're 6 foot tall, you got bigger stride, I guess. Well, off the top of my head, I'm going to suggest 5,000 hours. And again, off the top of my head, I'm not using any calculators or Google for this. 206 days.
Let me just have a look at that, Dave.
Please do, yeah.
I'll tell you what, you're pretty close. It is actually 206 days. So
Well, there you go.
Well done, Dave.
That's just a guess, just a guess.
I'll tell you something, we never rehearse anything here on Astro Radio. We always do it as it comes in.
It's live. We don't have scripts.
It's live radio. It's live radio. Anyway, James, what do you reckon on the discovery today well, I mean, it's not a discovery water on the moon. They have discovered water on the moon in the polar areas before. But what do you reckon on this finding that they reckon that there is water on the sunlit part of the moon? James has frozen again.
Yep.
So log out, James, if you can't hear us, and log back in. Simon, what do you reckon?
What they were coming back from a flight and they decided to point Sophia's instruments at the moon on the way back, and they discovered 2 years ago that they had an odd signal. It's taken them this long to report it.
Yeah. That's skeptical. That's from Mr. Skeptical in Bath.
What are you trying to suggest, Simon?
What are you trying to say?
You know, this infrared telescope, how big is it? It's huge, isn't it?
Yeah, house in a 747.
In a 747, just had the doors open when the moon was out.
And on the way back from a main mission. Yeah,
and they just took a
measure.
pointed at the moon, and they recorded molecules of water.
Yeah. I mean,
it sounds like you got doubts, I'm afraid.
I think
I haven't got doubts. We do a whole course, a STEM course for the kids on how you'd live on the moon.
Yeah.
And we've known for years about the water in the unlit craters when there's sunlight. But we've also known that the interaction on the surface creates what probably is, it produces hydroxyl groups, which is most probably water. So the bombardment in the regolith has got water. So we've known that for years. It's just this measurement actually proves it. The 6.1 micron measurement proves it's actually water, and it's not household bleach. So it's not President Trump or anything like that trying to ward off coronavirus.
Yeah.
And we're not talking about a puddle either, Simon, is my understanding. We're talking about a 2-liter bottle of water suspended in tons and tons of regolith here.
Yeah, so it's about every cubic meter of regolith is going to have about half a wine bottle full. So if you like your wine, it's about half a bottle's worth per cubic meter.
And this is drinking water in fact, isn't it?
Yeah.
It's not some other type of water, because I know we're trying to find water on comets and it was the wrong type of H2O, and so it is the correct type of water that if we go and try and live on the moon, we'll be able to extract water for drinking purposes and other use.
So James, what are your views on this, on the discovery today?
I think it's awesome, especially for future colonies. It's going to be a resource that obviously you can't take with you, so it could be a future source, obviously, of drinking water, fuel, hydrogen, oxygen mix. It just opens up the whole possibility of future lunar exploration and manned missions, having resources available. So yeah, fantastic news for me.
Do you know what fascinates me is the fact that eventually there will be lunar bases. I'm sure there'll be lunar bases. There's astronomers in lunar bases observing the Earth.
Yeah, I can believe that actually. Yeah.
Yeah, looking for intelligent life.
Yeah, people writing books on how to image the Earth.
Lots of filters. It's pretty bright, isn't it? Isn't it like 20 times brighter than a full moon the other way around?
Yeah.
Yeah. I think the moon is, the Earth is 3 degrees diameter as seen from the moon. So again, that's if you think of it in the sky, that is as wide as the belt of Orion would be the Earth, which would be pretty spectacular, wouldn't it?
Yeah.
The other interesting point. Go ahead, James.
No, so I was saying you'd be challenging each other to see the smallest detail you can find on the Earth.
Yeah.
The Great Wall of China.
Great Wall of China, yeah.
There you go, that'd be the favourite one. The pyramids, maybe.
Yeah.
Or my shed.
A strange thing that popped into my understanding recently that I'd never considered, because I'm used to seeing the moon rises when the Apollo missions took place years ago. That is indeed, if you lived on the moon, the Earth rise that you would see, but from the Apollo missions, if you lived on the moon, the Earth would always be in the exact same position in the sky for your entire life. It doesn't rise and set and transfer across the sky like we do here.
Funny thing on that one, Frank, it's somebody's just emailed in with a question on that, and it's Jill in Dublin again. She emailed, would the moon always be in the same place in the sky? The Earth always be in the same place in the sky from the moon? And you've just answered a question for her there. Yeah, it would be, wouldn't it?
Extra points.
Yeah.
If you go to and download the software Stellarium, you can go to any of the planets or the moon and look back at the Earth and test that theory out. Does it set? Does it rise? What does it do?
It's interesting.
Well, it's going to move a little bit, hasn't it? But it will move a little bit, but pretty much.
Yeah, there'd be a slight movement. Yeah, I think Daz has got a point there.
Just following on from Frank, when you're observing the Earth and all that, when we'll be actually observing a full lunar eclipse, not lunar eclipse, when the moon becomes eclipsed by the Earth and that, if you were on the moon, all you would see is the Earth, and you would see a red ring around the whole of the outside, and that'll be every sunset and every sunrise on the Earth at the same time.
That's interesting.
These are things to look forward to when we get that moon base, isn't it?
I think, James, you're getting a lot of ideas here for a new book.
I am actually. That's a goosebump one.
It is. That'd be a great thing to see. Yeah,
it would be, wouldn't it? It'd be really, really, really interesting. I think with your new book, you've got to start off with what shapes can you see on the moon?
Absolutely.
And also Clavius. Let's see what minerals are in Clavius. I'm curious about that one.
Yeah. I mean, there's a nice stripe across Clavius. I don't know if you've seen that from the images.
I'm sure I've heard of it via the BAA and the lunar reports. There's observations of Bandon. Yeah.
There's a nice stripe that runs straight across it. I've picked it up on my images. It looks really nice, actually.
I think that might be on page 120. I'll have a look at that.
It could well be. Have a look.
He thinks I'm joking. It is. Yeah. With regard to the water that's on the moon, my initial thought was it's trapped within the lunar soil or the regolith. Now I'm hearing it's embedded in glass beads, which may be from meteor impact. Where it's melted the lunar soil and formed these glass beads. Has anyone picked up on that?
I saw that just before I came up into the studio to switch over from the satellite. I did see. I read that somewhere, and I didn't really read too much of it, but it was something to do with it's being embedded in glass beads. Yeah. Yeah.
So that leads us to the problem of how do you extract water from this glass bead or these beads?
That'd be high energy intensive process, I expect. Yeah. Not very easy.
I was just looking at Clavius right now. It also has one of those. What do you call those when you have a craters on the moon and they line up like a machine gun shot, one right after another?
Like carpet bombing.
Carpet bomb, something like that. There's a set of those in Clavius too. It also looks like.
It's Cantina.
There's quite a few different areas where something's come in and it's deposited in a line.
It's like a crater chain.
Yeah,
crater chain. There we go.
One called the Davy crater chain, which is
it's called a cantina because they actually happen on lots of moons and other planets. Mm-hmm. We've even got them on Earth. Apparently, they found lines of meteor strikes. On the Earth, and yes, they're called a cantina.
Yeah, it's where the meteor breaks up as it enters and forms, the trail as it impacts the surface.
Oh, look what I've got here. Exactly. I've got the paper on it now. That's spooky. Yeah, they're called a cantina.
Yeah. One of our regular listeners, Derek, has just texted me, and he says he was bought a plot of land on the moon, and he's wondering how much it would be worth if NASA wanted to build a base on his land, especially if it's got water. Has his price just gone up?
I should sell now, Derek.
Yeah.
Oh, now while the going's good.
Yeah, sell.
The premium plot.
That's it.
Because if Simon gets onto the committee, he'll make sure that there's no water in your area. I know he will.
Because he'd be buying all the land up. We know.
I don't think you can own it.
Well,
can you?
Well, they're saying that you can't own the moon, but they're talking about putting is it G4 transmitters up on the moon?
Oh yeah.
You know, so if you don't own it, how come people can do all this? You know.
God, as long as they don't put.
That's upset the radio telescope people.
Yeah.
Thinking about putting radio telescopes in the craters, north and south, and now they're going to be interrupted with 4G, and
oh dear.
I get a signal. That's quite right.
Yeah.
I'll be able to phone home, but yeah, they're not very happy about that. Oh dear, it's Starlink all over again.
Oh dear.
Don't start on the Starlink thing. You'll get us all going again. Another question has come in, and somebody, who is this? It's Jill in Dublin again. She said, would it be possible to have unlimited power on the moon from solar power? Well, pretty much, I suppose, if you set up solar power, because you
you only have it for a fortnight, so you'd have to put it up on the north or south poles. There's certain places they've identified where they could have 24/7 power, but only at the poles.
Wasn't there a paper many years ago when in the 90s, I think, and they were on about if you put a ring of solar panels all the way around the equator of the moon, then that will be unlimited power. But that was a long time ago, and they never did it. So I haven't got to worry too much about it. Anyway.
I was just thinking there, Pete. If you were to walk around the moon and drop a panel on the floor, it'd take you maybe 206 days to do that. If you walk fast,
days, you could create that. So
yeah, you could do it.
It's a plan. It's a plan. Simon's now.
Now you got an interesting piece of moon here now.
Remember your radio, gentlemen?
Yeah. It's a beautiful image, a bit turbulent.
I shall describe what we're seeing at the moment. We're seeing an image on the screen, and you will be able to see that on Astro TV a little bit later when I put the video up, of the lunar surface. What area are we looking at there, Simon?
It's the side of Mariabrium. It's the one with
Sinus Iridium.
That's the one.
Yeah, and Plateau just to the bottom.
Oh, they're your favourite object there, James.
Yeah, I love that. Yeah. So the Bay of Rainbows, as it's known.
Isn't that also called the Golden Handle?
It is. Yes, as that bay comes around to our left on screen. Simon, with your cursor, can you move to the left? So right over to the left to there's a point called the Moon Maiden. Have you ever come across that term, the Moon Maiden?
Yeah, it's a clear obscure effect again on
That's
that side.
Yeah. Now the sunlight has got to be coming in at the right angle, so the terminator's just got to be right, and you get this profile of a lady's face, and her hair is blown in the wind. Seen it a couple of times. You've got to get it just right, like the Lunar X. It's a matter of hours. If you don't get it right, you miss it.
So, Simon, for the listener, what equipment are you using to produce that image?
It's I'm trying to remember now. It's an ASA 290 that's sitting on ASI 290 sitting on the back of a C11. It's a Celestron on a CGX mount.
So it's gone a bit dark at the moment, I think.
It's got clouds. Someone's bought something online.
Cloud magnet.
Yeah.
Here we have live on Astro Radio cloud. Get any better than that? I mean, and it's good. Cloud on radio, it works well.
Yeah, that's practical astronomy. Clouds.
Yeah,
trying to come back.
this is like the time I was on the BBC, and they wanted me to do a whole show on the BBC on how to image the sun live. How does that work on radio? But we just stood there going, I have now pointed the telescope at the sun, and I'm now pressing the button. But this is, you know, this is cloud in Bath, something that's actually unheard of in the south of England. But it is cloud, and we can verify that it's gone very dark. So while it's gone very dark, I think we'll go to another track. Let's have a look what we'll have. We'll have something appropriate, and we'll have Duran Duran and New Moon on Monday. Oh, it's coming out again.
I'm impressed with all your moon songs, Pete.
That face is where you're talking about. I pulled up an image of it. You're right. If the Terminator would just be
okay.
The pig on the moon.
YouTube later.
So we're looking at where we are, Clavius, and we got a bit of cloud going over, but we can see it. It's looking good.
Tycho, and you can see the ejector ray patterns sort of shooting down,
coming up from the.
Yeah,
I do love that area of the moon. It's a really nice area. For anybody that's listening to the radio show part of this, they won't hear this bit because it's on the video bit.
Okay.
But this will be on YouTube later, this video bit, or we'll put that up on YouTube later. But yeah, no, that's great, Simon, to be able to do that. That's brilliant.
You know, I was talking before, James, about asked you if you had considered doing any of the LROC stuff yourself, and I thought, well, you know, why would you? Your pictures are so great the way they are. But it just dawned on me that would be your only opportunity to do the backside and some of those awesome looking craters that we see back from there.
Yeah, absolutely. Yeah, and it never really crossed my mind to do that, to be honest. You've given me a really great idea there.
I think Kevin McGill, there's a couple guys, if you search, Sheen Doran is a guy that does videos just from the space station.
Okay.
I think there's a Kevin McGill that does Mars.
Yeah, no, it's definitely something I want to try. Like I say, the level of detail is unprecedented for the LRO, so it's something I'm going to give a go at. But I've never considered it before, so thanks for that idea.
It's well worth doing, because one of the projects I've got to do for Cardiff University is we've got to teach kids how to take Mars images and enhance them and get more detail out of them and more data out of them. So you could do, you know, obviously you could be able to do that with the moon. I think there is actually raw data that you can get, the raw data that hasn't been processed.
Right, that'll be even better. Yeah.
I'll see if I can find the details for you. Yeah,
absolutely. I know you can. I've seen people doing it with Juno cameras and all the raw data from that. So I suppose it's a similar thing. Yeah, no, I appreciate that, Pete. If you could,
there's a load out there. I'll find out for you. I'll ask the university where they get it from.
That'd be great. Absolutely. Yeah, you can see the golden handle again on Sinus Iridium.
Right.
You can see it shining along the edge and the maiden. Yeah.
Whole of the moon there.
How tall is that mountain range? Do we know?
We're not looking at the whole of the moon at the moment, but
12,000 feet.
Parts of the moon that Simon's now showing us, and we're back up to the plateau area of the moon, which is a very rugged area. There's some nice scars just below Plato, the crater. So if you take your telescope out and have a look on the YouTube video later on Astro TV, www.astrotv.earth, you'll be able to see some of these images that Simon is now drawing a little circle around the crater Plato. Beautiful flat bottom area to Plato. It's like a sea within a crater. Any idea what's caused that to be so smooth in the bottom of that crater? It must have been some sort of activity many years ago.
Yeah, I think some of these craters have upflows of lava in the past, which level out the bottom, so you can't see the central peak. And I think Plateau was one of those craters that had an upwelling of lava, just to give it a nice flat bottom.
It is. It's a beauty. I mean, it's a very striking crater, and of course you've got the rugged area around it. Then you've got the scar. I don't know what is the name of that scar.
What's the name now? It's got a mind block.
Draw a circle around it, Simon, so people on the video can see where that scar is. It's quite striking even through a small telescope.
The Alpine Valley.
Alpine Valley, and there's a real fine rill that runs down the centre of that as well.
That's it. Good test for the optics, isn't it? Good aperture,
yeah.
And you'll see it a string of a rill with craters along it.
Yeah.
That's right.
Is Hadley Rill visible at the moment? Can you get down and see if we can see anything near Hadley Rill? Hadley Rill being, for listener, it's an area where Apollo 15 landed. And it's an area, when I'm observing the moon, I always go to Hadley, have a look for Hadley Rill when it's visible. It's near the Apennine mountain range. And so you can, if you go and look at the photographs of Apollo 15 and the rover and them driving up to the edge of the rill, then you can look down on the rill and see where the rover, you won't see the rover obviously, but you will see the area where they would have been. As Dave put it earlier, he said the bend in the rill. I say the bend in the river myself, but it does look, rills look like a river. I think we had a question here on Astro Radio the other night.
We did, yeah. Kate in London asked, didn't she, what is a rill on the moon?
Yeah. And it's,
any thoughts there, James?
A rill, I think it's like I say, it's like a crack or a collapsed lava tube that forms like a valley really across the surface of the moon. So that you find them all over, and there's a lot of famous ones. Like I say, the Hadley Rill is an example, and it does just sort of flow around like a river. Yeah.
They do. That's striking because when you observe them through a telescope, they do look like a little riverbed, don't they? They've got that twist and turn and the bends in the river, and the Hadley Rill does look like a little flowing river.
Yeah.
Close to the Apennine Mountains and Hadley Rill is the crater Copernicus. How wide is that crater? Anybody got any ideas on how wide that crater is, or look it up on the?
I'll tell you in a moment.
60 miles.
It's quite a large crater. It's got some lovely crater walls, and of course it's got a peak in the middle. One of the questions actually that has come in, and this is from Mark in Southampton. He said, "How do those mountains form in the middle of a crater?"
They're part of the impact.
Yeah.
So, what happens is when the meteor or the asteroid hits, the rock starts to behave a bit like a liquid.
Yeah.
Have you ever seen slow motion of a droplet hitting a flat surface of water? You see it dips down in, that's causing the crater. And then just in the middle, you get a little droplet that pops back out again, and that's the mountain. And the way that the rock flows during the impact is very similar to that. That's why you get mountains in the middle.
It's like throwing a stone in mud, isn't it? You always get that peak in the centre as it drops down. Ron said, what was it, Ron? 50 mile?
I thought it was about 60.
Yeah.
93 kilometres.
Between 50, 60 mile. Yeah.
So that's, I mean, that distance, and you see that crater so clearly. I mean, you can see it clearly in that crater in a small telescope, or even a pair of binoculars. You can make that crater out.
You can see the ejecta patterns from, like I say, through a pair of binoculars easily. They're so bright, and they're spread for hundreds of kilometres across the surface. You can see the ejecta patterns there on screen really clearly.
Now, Lynyd Redruth said, you mentioned earlier when we were down at the other end of the moon, you mentioned ejecta when we were talking about Clavius. You mentioned ejecta and rays from Tycho. Yeah. She said, what do you mean by ejecta and rays from Tycho?
Yeah, so because Tycho is a fairly recent impacted crater, and so is Copernicus, you can still see the debris that's been thrown out from the impact. So all the ejecta rays are essentially all the debris thrown out during that collision. It goes in all directions for hundreds of kilometres. So they're very prominent on Copernicus and Tycho. They're two of the main fairly new craters where the ejecta rays are still really, really bright.
Would you say that?
And these are naked eye visible, also, I believe, aren't they?
Yeah,
absolutely. Yeah. All craters have them, but I think a lot of the older ones, I think that they do degrade over time. So the fact that we can still see Tycho and Copernicus, it's really because of fairly recently impacted craters compared to the rest of them.
And also with the ejector, I mean, does the ejector contain more sort of I wouldn't say glassy, but yeah, it's kind of from the impact, has it's kind of more glassy material that causes it to shine like it does, or?
Yeah, I think as it gets molten, it sort of changes its form into a more glassy form, which will do exactly that. Yeah, it lights up in the sky when the sunlight hits it.
But it is quite visible, you know, even with a small pair of binoculars, you can see the rays from Tycho very, very easily. It is a lovely sight. So Simon, you're still having trouble with clouds down there in Bath?
Yep. Someone's definitely on eBay buying something right now.
Right now in Bath, it's incredible. So we'll go to another track and we'll come back in a little while. Let's have a look what we've got. Let's look at track Ed Guy and Under the Moon. God, that's a heavy track. Blooming hell, it nearly blew my ears.
I am impressed with the number of moon tracks you've got, Pete. I have to be honest.
I've got hundreds, but I thought I've tried to keep the lighter ones. I've got some death metal tracks.
Oh, have you? All right, that might win.
I thought we'll try and steer clear of that till we do the rock show.
Yeah.
Simon's displaying on the screen at the moment. He's displaying, for those that are going to look at the YouTube channel later, he's displaying Mars live. And I've got to put this on, and they won't hear it in the chat there, but I will. And it's Jeff Wayne's Eve of the War. So what we're looking at there, Simon?
It's Mars.
It's Mars.
It's the sky's really moving. The seeing is really quite bad tonight. But
can you knock the exposure down, Simon?
Yeah, we'll do if I can.
I see, because the clouds are in and out. It's varying the brightness, because the polar cap is just visible just below the 9 o'clock position. That your cursor's showing it there. Yeah.
When I went out the door before and it was slightly clear, Mars was actually scintillating. That's how bad the seeing is.
Really? So overdubbing over that while you were talking, underneath it was running the Richard Burton bit.
Who'd ever believed?
No one believed. But that is unbelievable. So we can see there the I can see on my screen here. I think I can make out the polar cap there. But it is, like you say, the seeing is pretty bad. Anyway, so what we're going to do now, we're going to go over to some listeners' questions. And at the same time, we can sit here and look at Mars while we have the listeners' questions. So that's really good for us here on the video side of it. So listeners' questions there, Dave?
Yeah, we got quite a few moon ones. Obviously, topic of the day, I think. Question coming: how was the moon formed?
Who wants to go with that one? I mean, there's a theory, isn't there? There's a theory. Gaia and Thea. Thea impacts. Is it Thea impacts Gaia or Gaia impacts Thea? One way round or the other. But one impacts as a glancing blow against the other. One being a Mars-sized object. And the theory is that the material that is thrown off forms two moons that eventually coalesce into one. That's one of the theories. There are many theories, but I think that's the strongest theory as we know at present.
Yeah, Thea's the strongest theory now, and they've actually just recently announced a paper where they've analysed the Apollo rocks again, and they found minerals and crystallization that actually supports that theory. Doesn't prove it, but it supports that it was formed from a big major impact, which basically destroyed all of Thea. And took a big chunk of the Earth out, about 2/3. It formed a debris field around the remains of Earth. The big chunks all fell back to Earth again to start reforming Earth, and then it left a debris field, an accretion disk, where the moons, as Pete said, there is a theory that two moons actually formed in the same orbit. With one slightly smaller, traveling a little bit faster than what the moon we have at the moment. And when they actually caught up with each other, the smaller, because it was moving so slow and it was still malleable, the smaller moon actually molded itself around the back, the back side of the moon, the far side of the moon. So that's why one of the theories is the far side has a thicker crust than the near side. There are other theories as regards that, of course, you've got a big Earth that's still molten on one side of the moon. And of course, the moon was a lot closer at that time. So it kept that side of the moon a bit more molten, in the backside solidified quicker. But that's the main theory at the moment, the Theia theory. Of course, there was the theory that Charles Darwin's son come out with, which I can't remember what it was called, where a big chunk of the Earth flew off and formed, which left a big hole, which was the Pacific Ocean, and that actually went out to form the moon. So there's several theories.
I think the main thing is with the Theia theory. Trying to say that's bad enough. Theia theory is the fact that the moon rocks didn't show any material from the inner part of the Earth. It was only the crust, Earth's crust, and that sort of area. So they said it had to be a glancing blow, not a full blow onto the Earth to cause that, because you would have got material from the inner part of the Earth. So there we go. So I think that's answered the question. Dave, do you think?
Yeah, but it also brings us into another question. Is the moon moving away from the Earth?
Yep.
And if so, how do we know it's moving from the Earth?
Well, it depends if you believe in the Apollo landings. But if you believe in the Apollo landings, then they put reflectors down, laser reflectors, sort of prisms on the moon. And we can fire a laser at the moon and it reflects off those. And we can accurately measure the time between when we fire the laser and when we get the light back. And that gives us a distance measure, because you know how fast light travels. And we do that every year, and it's someone's job to actually keep doing this. And we find out it's moving about 2 centimeters, 3 centimeters away from us each year.
That's answered.
Yeah, it's moving, as you say, about 1.5 inches or approximately 4 centimeters per annum. But I think there's actual an observatory site that you can go to and see that getting done. You can actually do it live.
I think it might be McDonald Observatory in Texas.
Yeah,
I think it might be.
That'd be one to look up, I think. Okay, so we now got an idea how the moon formed. We can say, yeah, it's moving away from the Earth, and eventually that means we'll lose our total eclipses. We'll have annular eclipses.
Exactly.
Eventually.
See them now.
But we'll lose our total eclipses. That'd be a shame.
It'd be a sad time. Yeah.
Yeah. I mean, I've been lucky to see 5 total eclipses of the sun. To think that there would never be any more, that would be very sad.
It'll have a few major effects on us when it eventually pulls away, because we're gravitationally tied at the moment, and of course that will decrease. Our tides will decrease. It acts as a brake on us, so we'll start to spin a bit faster. So we'll have to adjust our clocks and everything, have longer days. And of course the moon will start spinning again, so we will actually eventually see the far side of the moon, but it'll be further away.
Well, without getting too deep into Space 1999 again, because we tend to sidetrack, if the moon was to leave Earth's orbit, what effect do you think that would have? I mean, straight away, tides are going to be a problem. Gravity is going to be affected.
No tides at all.
End of the world.
No tides, because the water will eventually find its own.
No surfing.
Yeah.
No surfing.
Astronomers getting totally tired because they'd be out all the time because there'd be no moon to hinder them. Some people would be happy there, wouldn't they? But you could never say that the moon was never exciting after that moment.
Yeah, I think all the nighttime creatures as well who rely on the moon for navigating a bit, they'd be all thrown out. They'd be don't know where to go.
Derek's asking me, what about the effect on the weather? Because obviously your tidal, your thermal currents, was it the Tyroleus effect, all that? That's going to change. That's going to alter as well, isn't it?
There's got to be an effect. There's got to be an effect on the weather, surely.
Yeah.
It's going to have a big effect eventually, but we haven't got to worry about it. It's millions and millions of years away. So
okay.
Unless there's an explosion on the far side of the moon.
That could never. The chances of that happening are 1,000,000 to 1. They say, but well, okay then. Answer me this one, moon experts. Why is the moon larger when it's closer to the horizon? The famous moon illusion.
We were going to give this one to Simon, weren't we?
That's fair.
Come on, Simon.
It's just purely an optical illusion. That's because you've got a reference point. When you look up above you, you've got no reference point. But when you've got a reference point of the horizon, then your eye tries, or your brain tries to correct the fact that it's seeing something far away and something close to, and that gives you the illusion. But if you just hold your little finger up and at arm's length, it'll cover the moon, and if you do the same when it's high in the sky, it'll actually, your same finger will cover it by the same amount. So it hasn't changed, it's just purely an illusion.
So it's just your brain playing tricks on you, isn't it?
Yep.
That's it. Yeah. I remember doing this as an experiment in the days of film camera. I'm sure you can do it with a digital camera these days, but we'd take a photograph of the full moon as it's rising when it looked large, and then we'd wait several hours till it got higher in the sky where it appeared to be smaller, take an image again. And in those days, we'd look at the film, the 35mm film, and look at the size and measure the disc on the film. And it was exactly the same size. Because it would be strange if the moon did expand and contract over a couple of hours, wouldn't it? That'd be a problem in itself. Okay, so for the high resolution imaging that we've seen James produce, what about the flag on the moon? Can you see the flag on the moon with your telescope?
Unfortunately not. I've tried, but unfortunately ground-based telescopes are not enough. Even the lunar reconnaissance orbiter can't quite see the flag, I don't think.
Right.
But,
Yeah.
It can see
Yeah.
the shadow.
I think the best resolution sort of a backyard scope can see is probably 1 to 2 kilometers diameter, really. So not much challenge, really.
Yeah, but the probes have orbited the moon and imaged the sites, haven't they, of the lunar images? You can see the lander, you can see the shadow of the lander.
You can see the trails from the buggies and everything, so you can see a lot of information from there. And,
you can see where my lovely Apollo 15 lunar rover drove to Hadley Rill as well.
Yeah.
If you go on the NASA site and then log on to the LRO mission, they have got a whole section on where you can actually view all the Apollo sites.
Yeah.
And you can see all these. You can even see the little heaps of detritus that they left on there, and you don't want to know what's in those. So.
Oh yes, those bags. Wait, lunar deposits, I believe. Yes.
Anyway, we're going to go over to another couple of tracks, and then we'll come back for the last 5 minutes of questions and answers tonight. So this is Pete, this is Astro Radio, this is Reach Out and Touch Space, and this is Malice in Wonderland with Moonchild. Another moon track there.
Yeah, unbelievable.
Derek's just asking.
It'll take quite a while for that work. There was also talk of sending up 3 or 4 satellites and just parking them right alongside.
Gravity tractors, yeah.
Yeah, and the microgravity that they will exert on it will slowly pull it away. But there's nothing that you could do straight away to make a drastic change.
You can put an engine on it. You can use laser ablators. So effectively you fire a laser at it and that actually causes the thrust off it. Yeah.
So the biggest no-no is firing a nuclear rocket or missile at it. Because you end up with lots of impact possibilities then.
Yeah, if it penetrates, it's
great for sci-fi movies, but not good for reality.
The biggest no-no is for Space Force to go up there and just instead of it impacting the east coast of the United States, it just nudges it a few thousand miles east. That would be the biggest no-no.
I always judge sci-fi films on how good they are. If Big Ben is still standing, that's a good film. The aliens are always going to land on the White House lawn.
That's true.
So and some say that happened 4 or 8 years ago. That happened. So
you talk about that.
All these possibilities.
They've released all this cockpit data and imaging from the U.S. Air Force of these unidentified flying objects, and they're talking about they want to set up a commission to analyze all these images and all that to see what they actually are. I mean, talk about wasting money.
In the last 2 weeks, there's been 2 jetpack men seen over LAX in the United States.
Well, I don't know if those who listen to the Locked In shows we did a while back, we actually had a guy on that had been involved with Project Blue Book back in the 50s, and 60s. So that was very interesting, because like their project was to disprove everything.
Yeah.
And he actually said that there were 2 or 3 things that they couldn't disprove. Obviously, we got more understanding now what some of these things are, but back then they didn't. And he said it was interesting.
Yeah, they were the precursor to the Men in Black, weren't they? So I can remember there was a TV series called The Blue Book Files.
Yeah.
Many years ago, and that I watched that. That was quite interesting. But yeah, it was basically just set up to prove things and all that. And if you didn't comply, then you disappeared.
What I don't understand, Daz, is we as amateur astronomers are constantly looking up in the sky. We have high resolution telescopes and images, yet with the rose-blade photographs that we see. I think we're moving over to Peter now towards the end of the show.
I want to thank James for coming in onto Astro Radio tonight. And James, you're welcome anytime. Just come in and join the panel when you've got a free moment. We're always, Mondays, Thursdays and Saturdays we're on. This Saturday is the Halloween special, and Pramvira from the United States is coming in, and she says we've all got to dress up in something Halloween. So that's going to be. I've got my
that sounds fun.
So we're going to go out tonight, and thank the panel very much for joining us as well. We're going to go out tonight with JJ Cale and Cajun Moon. Okay, guys.
Thank you, James.
Thank you, James. Excellent.
It's been great fun, honestly. I really appreciate the invite. Absolutely.
You're welcome anytime. That's the idea of it.
It's an open house.
Yeah.
And you come in, if you want to pop in for 10 minutes, you do, you get out, whatever. If you want to observe at the same time, like Simon, do so. And then you can share the images. Great. If you've got images we can put that on screen as well.
Yeah. Well, there's things to do. Absolutely. No, I really appreciate it. Honestly,
no problem.
I've had great fun.
Well, hopefully we plugged your book. I'm sure sales will peak tonight around the world.
I hope so. We'll see.
Yeah. We've been peaking up at around 275,000 listeners tonight. So
wow, that is unreal, actually. Yeah.
It is when you think there's only how many of us? 6, 7 of us in the room. There's listening.
Have you got a Southern Sky issue with this, with all the moons upside down?
Yeah, he just turned the book upside down.
That's it. Can read it upside down, he'll be okay.